Texan Global School. Quadratic equations. This class discusses the definition of a quadratic equation and its solution methods. A polynomial equation of the form x squared plus b x plus c equals 0 is called a second-degree equation or a quadratic equation in the variable x. Where a is the numerical coefficient of the quadratic term, b is the numerical coefficient of the linear term, and c is the independent term. This form is also called the standard form of a quadratic equation. The graphical representation of a quadratic equation is a parabola. It is constructed by setting the equation equal to 0. Then, substituting the 0 for the dependent variable y. And it is tabulated to plot the points on the Cartesian plane. This example will graph the quadratic equation x squared minus 4 equals 0. Since the equation is already set equal to 0, we will substitute y for the 0. Now, we tabulate by proposing values of x and substituting them into the equation to obtain the values of y. In this way, we obtain ordered pairs x, y. We can see that the points P of coordinates -2, 0 and 2, 0 are highlighted, since they are the points of intersection of the parabola with the x-axis. This means that they are the solutions to the equation. By plotting the points obtained in the tabulation, we can see the shape of the parabola and its intersection at the points mentioned, which are the solution of the quadratic equation, when x is equal to 2 and -2. We will then see the methods to obtain the solutions to an equation. A second-degree equation or quadratic equation can have up to 2 solutions. There are 3 methods to solve them: by factoring, completing the square, and using the quadratic formula. The process for solving a quadratic equation by factoring involves setting the equation equal to 0. Then, we must factor the polynomial. We set each factor equal to 0 and isolate the variable in each of the 2 cases. Let's look at the first example. We will solve, by factoring, the equation x squared minus 4 equals 0. Since the equation is already set equal to 0, then we factor. We can see a difference of squares that factors as conjugate binomials. Performing the square root of each term gives us the factors of x plus 2 times x minus 2. Now, we set each factor equal to 0 independently and isolate the variable x. In this way, we obtain that the equation x squared minus 4 equals 0 has 2 solutions, also called roots of the equation. When x is equal to -2 and when x is equal to 2. As we saw before, the solutions represent, graphically, the points of intersection with the x-axis. To verify if the results are correct, we must substitute each value, independently, in the equation. We can see that both equalities are satisfied, indicating that both values are correct. In the following example, we first set the equation equal to 0. We can see that we have a trinomial of the form x squared plus b x plus c, which is factored by looking for 2 numbers that, multiplied, give -3 and added, +2. Then, the factors are x plus 3 times x minus 1. We set each factor equal to 0 and isolate the variable, thus obtaining 2 solutions, when x equals -3 and when x equals 1. Also, to verify, we substitute the values into the original equation. We can see that both solutions satisfy the equality. For this example, we can see that we have a trinomial of the form x squared plus b x plus c. We must apply the cross-section or scissors method to factor. In this case, we have 2 possible arrays of scissors. Analyzing both cases, we can see that the second array is the correct one, since the first has a common factor of 2. By analyzing the signs, we can see that the factors are 2x minus 1 times x minus 2. Now, we set each factor equal to 0 and isolate the variable, thus obtaining 2 solutions, when x equals 1/2 and when x equals 2. Also, to verify, we substitute the values into the original equation. We can see that both solutions satisfy the equality. The following method for solving quadratic equations is by completing the square. The process involves setting the equation equal to 0. Then, in case the numerical coefficient of the quadratic term is different from 1, we must multiply both sides of the equation by its multiplicative inverse to make it 1. Then, we send the independent term to the right side of the equation. So, we multiply the numerical coefficient of the linear term b by a half, and we square the result. The value obtained must be added to both sides of the equation. In this way, a perfect square trinomial is obtained, which factors as a binomial squared. Finally, the variable x is isolated, applying the square root on both sides of the equation. This next example will solve the equation by completing the square. In this case, the equation is already set equal to 0, and the numerical coefficient of the quadratic term is 1. So, using properties of equalities, we send the independent term -3, as +3, to the right side of the equation. Now, we multiply the numerical coefficient of the linear term 2 by half and square the result. In this case, we obtain 1. This value is added to both sides of the equation so as not to alter it. In this way, we have completed a perfect square trinomial on the left side of the equation. So, we factor the perfect square trinomial as a squared binomial. This can be factored as a trinomial of the form x squared plus b, x plus c. That is, looking for two numbers that multiplied give the independent term and added the numerical coefficient of the linear term. However, we will always obtain a perfect square trinomial. This particular case is factored by taking the square root of the quadratic term and the independent term, and substituting them into the squared binomial formula as shown. The sign of the binomial is always determined by the linear term, in this case, positive. Finally, we isolate the variable. It is very important to understand that, by applying the square root to both sides of the equation, the result implies having two solutions. One positive and one negative. So, separating each root, results that x is equal to 1 and -3. In this next example, we will solve the equation and complete the square. Since it is already set equal to 0, we will now multiply both sides of the equation by the multiplicative inverse of the numerical coefficient of the quadratic term, to make it 1. Now, we will send the independent term to the right side of the equation using properties of equalities. We then multiply the numerical coefficient of the linear term, -5/2, by 1/2 and square the result. The value obtained is added to both sides of the equation so as not to alter it. In this way, we complete the perfect square trinomial. We factor as a squared binomial, taking into account that, in this case, it is negative. And we isolate x, resulting in two values from the equation, x equals 2.5. The last method to solve quadratic equations is by using the quadratic formula. This formula can be proved by applying the process for completing the square to the standard form of the quadratic equation. So, we will use the quadratic formula for solving quadratic equations by first setting the equation equal to 0. Next, we must identify the values of a, b, and c according to the standard form of the quadratic equation. Values are substituted into the quadratic formula. And finally, simplifying obtaining the roots of the equation. This last example will solve the given quadratic equation by the quadratic formula. Since the equation is already set equal to 0, we then identify the values of a, b, and c. We can see that a is equal to 1, b is 2, and c -3. We then substitute in the quadratic formula. We simplify, in order to obtain the roots of the equation. X equal to 1 and -3. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com